In the previous term, we were taught about the descriptive statistics. They give us useful information about the samples under investigation. But this time, we will no longer be describing the data set. Instead, we are to go further analysis. Many problems require that we decide whether or not a statement about the mean or the standard deviation is true or false. The statement is usually called a hypothesis, and the decision-making procedure about the truth or the falsity of the hypothesis is called hypothesis testing.
A statistical hypothesis is a statement about the probability distribution of a random variable. Likewise, it is a preconceived idea about the value of a population parameter which is verified through statistical procedures or tests. Statistical hypothesis involves one or more parameters of a given probability distribution. For example, suppose we are interested in the mean performance of principals. Say mean is 85. We may express this formally as null hypothesis. Mean is equal to 85 versus alternative hypothesis, mean is not equal to 85. H sub 0, where mean is equal to 85, is called the null hypothesis, and the statement H sub A, where mean is not equal to 85, is called the alternative hypothesis.
The null hypothesis, or the H null, and the mean is equals to 85, can be quickly verified by studying the entire population of principals to determine if the value of the population mean it specifies is true. If the whole population is studied, then the investigator will not make a wrong decision about the null hypothesis.
Similarly, we can also hypothesize that the two groups of population are the same or different, and we may express this as null hypothesis mean 1 is equal to mean 2 versus alternative hypothesis mean 1 is not equal to mean 2.
In most cases, however, due to time, inevitable constraints, the whole population cannot be studied. In such case, investigators resort to taking or selecting a random sample from the population being studied and based on the results gathered. We either accept or reject the null hypothesis. If the information gathered is consistent with the null hypothesis, then we would conclude that the null hypothesis is true, which leads to the acceptance of the null hypothesis. However, if the information gathered inconsistent with the null hypothesis, then we would conclude that the null hypothesis is false, which leads us to the rejection of the null hypothesis. If the null hypothesis is rejected, an alternative hypothesis is accepted. The alternative hypothesis includes all value not specified by the null hypothesis.
Directional and non-directional test of hypothesis. When a researcher hypothesized that individualized instruction is the same as that of the lecture method, what we actually meant was that students under the lecture method perform similarly than those students subjected to the lecture method. Thus, the hypothesis can be stated in the following manner. The mean score of the students under the individualized instruction method does not differ significantly than that of the lecture method. This can be expressed as H sub 0 mean 1 is equal to mean 2. The first alternative hypothesis allows for the possibility that either mean 1 is greater than or less than mean 2. In this case, we are making a non-directional two-tailed test, whereas the second alternative hypothesis states specifically that mean 1 is greater than mean 2. And similarly, for the third alternative hypothesis, where it is stated specifically that mean 1 is less than mean 2, in this case, we are making a directional one-tailed test.
Level of significance.
In any kind of test of hypothesis, we always ask whether the observed difference between the two groups of respondents is significant or just merely by chance. Answer to such query involves the use of probability level, alpha, called the level of significance of a test, which is set by the researcher prior to the gathering of the sample data. The level of significance of a test of hypothesis is usually set at 0.05, 5%, or 0.01% by most researchers.
Level of significance of 0.05 or 5% means that in a repeated sampling from a given population of interest, the probability of obtaining sample results similar to the one presently observed is 95%, and the probability of obtaining different sample results is 5%. Similar interpretation can be made regarding a 1% level of significance. Significance at a certain level of alternative hypothesis means that the probability of occurrence of the observed sample results due to plain chance or sampling error is equal to or less than alternative hypothesis. The smaller the probability is, or the smaller the value of alternative hypothesis, the more significant are the sample results.
Types of errors.
In the test of hypothesis, we always commit two types of errors, such as the type 1 error and the type 2 error. Type 1 error occurs if the null hypothesis is rejected when in fact it should be accepted. It is denoted by the alternative or the level of a significance, while one and alternative hypothesis is known as the confidence level. On the other hand, if the null hypothesis is accepted, when in fact it should be rejected, then we are committing a type 2 error.
A correct decision in hypothesis testing is made if the null hypothesis is accepted when it is really and should therefore be accepted. The probability of making this correct decision is 1 to beta. Hence, if the adopted level of the significance in conducting a test of hypothesis is 0.05, then the probability of correctly accepting a true hypothesis is 0.95.
A second correct decision in hypothesis testing is made if the null hypothesis is rejected when it is really false and should therefore be rejected. The probability of making this correct decision is 1 sub b. The power of a test is its ability to discriminate a true from a false hypothesis. In general, the power of a test increases as the number of observations in the sample increases. Steps of hypothesis testing.